So we have Jan-Philipp Weiler, who's going to talk about citational politics in their paper, We Are Who We Cite, Bridges of Influence Between Natural Language Processing and other academic fields.
All right, thanks for the introduction and welcome to the talk. So in this work, we looked at scientific influence, which means how much are ideas from one field influencing the ideas in another field. Say, for example, psychology, how much do the ideas from psychology influence ideas in NLP? And understanding this influence really helps us to understand where ideas originate from, what fosters innovation, what stifles this, or who are stakeholders in our field. And while this is interesting for any field of study, we particularly focus on NLP because NLP has sort of taken the world by storm right now, and we're influencing various different social applications, but also scientific applications. And one key point about scientific influence is that there are many different factors at play in this influence, but we also have an active role at shaping this influence. So we as researchers, we also sort of have this agency of the researcher in which we can choose whose literature to engage with and also benefit from. And also if we may happen to influence another field, we can choose to engage with their literature, workshops, and fields so that they're more aware of our work. And mechanisms of influence are complex, but we know that if I'm influenced by a paper, I should cite it. So citation is a key marker of this influence. And we do want to note that not all citations are equal, and there are various biases in these citations. But at an aggregate level, we argue, still meaningful inferences can be drawn on the behavior of influence. So because literature engagement ultimately leads to these citations, we argue who we cite says a lot about us, about our field, and also who cites us says a lot about us. So in this work, we trace hundreds of thousands of citations between NLP and various different research fields to examine broad trends of influence between them. So here are some key questions that we explore in this work. For example, which fields of study markedly influence NLP, or to what extent is NLP actually drawing from its immediate environment, being more insular, or are we a hotbed of cross-pollination, interacting a lot with various different research fields, and how have these things evolved over time? And some of them will be covered more in this talk because of time constraints. Others are available in the paper. The main data we use is Semantic Scholar, which is a repository of over 200 million papers and 2 billion citations. And Semantic Scholar categorizes papers into 23 high-level fields of study. So you'll find things like psychology, math, computer science, and so on. And NLP is not one of them, but NLP is sort of an interdisciplinary field that bridges multiple of them, like CS, linguistics, and so on. And we say a paper is in NLP when it is in the ACL ontology. So we take the ACL ontology as a proxy for NLP works, which is a high precision proxy for that. We also estimate subfields in computer science, like machine learning and computer vision, and we estimate subfields of NLP. They won't be much in this talk, but just so that you know, in the paper, we have a lot of experiments on that too. So the first question really is, which fields do we cite, and how did that change over time? And first, I want to show you a differentiation between computer science and non-computer science, and you'll see outgoing and incoming citations in this talk. So outgoing citations are from NLP to another field, and incoming citations are from another field to NLP. And we can see that in the 1990s, in the plot above A, we have cited, in the 1990s, we have cited 54% of citations to computer science. So if you take an average NLP paper from the 1990s, every other citation was to a CS paper. But ever since, this trend has strongly increased, and now in the 2020s, 83% of citations from NLP go to CS. So 4 out of 5 papers of an average NLP paper. And on the other way around, so CS cites us more too. In 1990s, we started 64% of citations are received from computer science in NLP, and now we're also at 81%. So 4 out of 5 citations an average NLP paper gets are from a CS paper. If we look into the non-CS part, so the other 22 fields, we've just seen CS, the other 22 fields, and here we've plotted the 4 most cited ones by NLP. We can also see some peculiar trends. Again, figure A, the outgoing citations, how much NLP cites that field. In the 2000, we've cited around 60% of the non-CS citations to linguistics, but that has decreased over time. And remember that the overall non-CS citations have decreased over time too. So this is a very strong decrease. Now only 26% of citations go to linguistic papers. And in the incoming part, it's pretty much the same. Linguistic also cites NLP less over time. So from 62%, we went down to 39%. It's interesting that we cite math much more since the 2010s, probably because we have more deep learning, machine learning models then, and we rely more on math. We don't see this mirroring on the incoming citations, which also sort of makes sense. Math probably doesn't advance their field as much with NLP. We also see an increase in psychology overall. So we do cite more psychology and we get cited more by psychology. And these two things already show us that we get much more CS-centric over time, and there's a waning influence of linguistics over time, and we have some more math that we cite, and psychology is also citing us more. But ideally, we want to quantify this diversity of citing a diverse set of fields in a singular value, so we can compare it to other fields. And that's why we introduced the Citation Field Diversity Index. And here's how you compute it. You take a paper's references and you categorize them into their respective fields. And then you count how many references are in which field. So let's say field A has 5, field B has 4. And on these counts, you apply a measure of inequality. Here we chose 1 minus the Gini. And a value close to 1 means that we're uniformly citing across all fields. So all fields get 2 citations. A value close to 0 means all of them are concentrated in a single field, like computer science. And now we can plot this for NLP and various other fields. So here are two plots. Here are two plots on the incoming and outgoing citations of NLP and the 3 most cited non-CS fields, as well as an average. In the outgoing case, you can see that math has started fairly low, has a stark increase, and then become more steady at 0.6. The average, linguistic, and psychology have been much higher, but then they also had a more steady slope. Now it reside at around 0.7. But the real outlier here being NLP. From the 1980s, there has been a small jump, but ever since it has been decreasing. And now NLP has reached all-time lows in their CFDI, in their diversity to cite across fields. And this is also the lowest value reported across fields. In the incoming case, we see similar trends. Again, we have sort of some increase in many of these non-CS fields. Recently, there has been a decrease, and NLP is standing out, again, decreasing quite substantially over time, reaching all-time lows. And again, the lowest value reported across these fields. Next, we want to get a feeling whether there's a difference in citing diversely across fields if a paper gathers more citations or less citations. So here we bin papers into different ranges of citations. So if they received 1 to 9 citations or more than 5,000 citations, and we do that for different time ranges to see whether highly cited papers cite more across fields than lowly cited papers. And here's some plots. So on the left, we start with 1965 to 90s and 90s to 2000s. And there's sort of a consistent trend that highly cited papers do cite more across fields than lowly cited papers. In the 1965s, there's this small arc down, but overall, it's an increasing trend. So papers who gather a lot of citations seem to have higher field diversity. If we go to the 2000s and 2010s, then this trend becomes more steady. Now, it doesn't matter how many citations the paper got, they have around the same field diversity. But recently, in the 2010s, well, now this has reversed. And highly cited papers have less field diversity, that they cite less across fields. And the important takeaway here is that highly cited papers are very visible to us. They influence a lot of researchers, and they are also paragons they're not paragons, but they are very visible to young researchers and serve as like templates for how to write a good paper. And this could be concerning because if they don't engage with a lot of literature outside of NLP, then maybe this can be seen by young researchers that this doesn't need to be done. Okay, finally, we also, now we looked at the cross-influence through citations. So how much do we cite different fields? How much do we get cited by different fields? But a paper itself, an NLP paper, can also be part of many fields. So it can be interdisciplinary. And we want to get a grasp on how interdisciplinary NLP is. So here, an NLP paper could belong to just NLP, but it could also be in math and psychology at the same time, or other fields. So a single paper being in multiple fields, and we quantify that by looking at how many fields a paper is in on average versus how many fields a paper is in for other fields. So maybe the plot is easier to understand. The red line shows the average number of fields per paper for fields other than NLP, and the black line shows the number of fields per paper for NLP. And the red line is sort of steadily increasing, which is consistent with related work that shows we are getting, on average in science, more interdisciplinary. So there's more fields per paper over time. While NLP has been diverging from that trend quite substantially again. They've both started around the same value in 1980s, but now NLP is just at 1.2 fields per paper, much lower than the average of other fields. Okay, to conclude this work, we've seen quite significant shifts in cross-field influence. NLP is decreasing in the diversity of citing various different fields, while other fields are actually remaining steady or increasing. We mainly draw ideas from CS, and if you look in the paper, specifically from ML and AI, and there's a waning influence of linguistics. Also, we've seen that highly cited papers now tend to have lower field diversity than before. And we also saw a decrease in interdisciplinarity, signs of becoming more insular and being less in multiple fields. And these trends should ideally give us pause and think about how we are influencing the broader exchange of ideas and how are we focusing excessively on CS at the expense of relevant work from other fields. And we've also created an interactive demo, so it's easy to compute that for a paper. So you can upload a PDF file, and it will tell you which different fields you have cited. What is your CFDI index? How does it compare to the average in NLP? Where are you in this distribution? You can also add a proceedings list or an author profile to compute these values for entire groups of papers. You can check it out on the QR code here. Okay, here's some key related works from us if you want to check them out. And that's it. Thank you.